Okay, so this problem is on page 3 of your study guide, and it has to do with similarity in right triangles. And so you can see we have a large right triangle right here, and they've drawn an altitude from the right angle perpendicular to the hypotenuse, dividing this into two more right triangles. So what we have is we have these two triangles here, and we have the small triangle that they've recopied over here so that we can see it as three triangles. So it's a little bit easier to view this if we take these out and put them over next to it. And one of the things that's missing from this picture is that this side is H. As you can see from right here, it's H. Okay, so we have a big triangle, which I have as our purple triangle, our medium triangle, aqua, and our small triangle, which is the pink. And what we're going to do is we're going to look at triangle 2 and 3, and we're going to use compare the two parts. So we're going to compare the legs of the triangle. So we're going to look at this triangle here, triangle 2. And for triangle 2, we're going to look for leg H because it has H right here. So H is the short leg on this triangle. So if I go over to my pink triangle, X should be the short leg on the pink triangle, and it is. So going back over to the middle triangle, the medium, the long leg is Y. So when I go over to my small triangle and I look for the long leg, here's the long leg here, and it's H. So this is going to be H. Now on the next problem, we have the shorter leg and the hypotenuse for triangle 1 and 3. So if we go to triangle 1 and we look for the shorter leg is here, and that's A, and you can see that's here. And we look at triangle 3 and the shorter leg is here, that's X, which is here. So now let's look for the hypotenuse. So the hypotenuse for this one goes from here to here, and that length is C. So this is going to be C. And then our hypotenuse for our small triangle is here, which will be A. So this will be A. Okay? All right. So now for the next problem, it says use the long leg in the hypotenuse, but they want us to compare triangle 1 and 2 this time. So comparing triangle 1 and 2, we've got the longer leg of triangle 1 is this one here, which is B. So that's B. And the longer leg of this one here is not this one. This is the hypotenuse. It's this, which is Y. And that's what they have down here. And then we're going to compare the hypotenuse. So the hypotenuse up here is C. We got that right there as well. And then the hypotenuse of this one we just said was B. So this is going to be B. Now I want you to notice that on this problem, for these two, these are the same letter, and so are these. And if you square these, we get A squared equals X times C. And then we take the square root, we call that A. This is actually a process of called finding the geometric mean. We're not going to test on that, but that's what it's called. Okay, so we're going to use these relationships to help us do this problem down here. But we can either look up here and use it, or we can use a chart, which is my preferred method. But before that, we're going to go ahead and label these sides. So we know that this side right here is 3, because it says right here A is 3. So this is 3. And we know that B is 4. So this is 4. Okay? And then they want us to find KL. And KL is the length of C. That's the same thing. And if you have a right triangle, and you know two legs, and you want to find the hypotenuse, we know that we can use Pythagorean theorem. And the Pythagorean theorem tells us that the leg squared plus the other leg squared equals the hypotenuse squared. And the hypotenuse we'll call KL. Okay, and you can go ahead and work out the arithmetic for this, but I know from working with right triangles over time is that we have something called a Pythagorean triple. So I know that 3, 4, and 5 make a right triangle, and that's one of the most common Pythagorean triples that we have. So without doing all the math, I know that KL is 5, but if you don't believe me, you can go ahead and do all the arithmetic and find that that's the answer. So now we have to find H. And if we look up here to use the relationships, this is the only equation that we have up here that has H in it. And if I were to try to find H, I would have a hard time because I need X and Y, and yet I don't know X and Y, which are the two pieces of the hypotenuse. There is a theorem that could tell us that and help us, but it still would give us multiple variables, and we need to come up with another way. So one of the things that I like to use is a chart. So let me just show you the chart that I've made here. So here's a chart that I've made, and it has to do with this problem here. And again, as I said, we already know that this is 3, and this is 4, and this is 5. Okay, so we know those pieces. So what I did for this chart is I remembered that I have 3 different triangles, the big triangle, the medium triangle, and the small triangle, all within this picture. And then I'm looking for the short side, the short leg, the long leg, and the hypotenuse. So I'm just going to go through and I'm going to put in what those are. So in my big triangle, we know that the short leg is A, and A is 3. So I'm not going to write A for this problem, I'm going to write 3. And then the long leg is here, and I know that the long leg is 4. And I know that my hypotenuse of my large triangle is 5. Okay, so those give me all of those sides. Now if I go to the medium triangle, which is here, this triangle here, okay, this is our short leg, and our short leg is H. So I'm going to go ahead and put H here. Our long leg is Y. And then our hypotenuse is B, which is 4. And then I'm going to go to the small triangle. And for the small triangle, that's this one up here. Okay? And for this triangle, I know that the short leg is X. The long leg is H. And the hypotenuse is 3. Now what I'm going to do is I'm going to look and see if I have any proportions that I could make within this. And to make a proportion, we need a fraction, and this is kind of set up already. Now I'm trying to solve for H. So, for example, I could put it like this, and this could be my proportion, H over Y equals X over H. But I don't know any of those, so that would not be helpful. And then I could do that for this one as well, down here. But again, I have 2 variables. So I want to try to find one that only has 1 variable. So if I come to this one over here, this is one of the ones that I see that has 1 variable. So I could solve for Y in this case by cross multiplying. And I'm just going to real quick show you how to do that. So remember that this is 4/5. So we're going to do, it's 4/5 equals Y over 4. And cross multiplying, we would get 16 equals 5Y. So we know that Y equals 16/5. But I'm not really looking for Y, so let's see if we can find another proportion that has just H. So again, my H's are all over in these 2 columns. And I want you to notice that if I cover up this middle column here, and I cover this top row, I will have a proportion that has only h in it. So I have 4 and 5, and then I have h and 3. And so that's the proportion that I'm going to want to use. So I'm going to use that proportion, 4 over 5 equals h over 3. And when I cross multiply, I really can just leave h where it is. So I'm going to multiply across. 3 times 4 is 12. We'll leave the denominator there, which is 5 and h. And now I know h. And so that's my answer for this problem. And I have finished. Okay, if I did need to find x and y, I have already found y, but I could go ahead and find x. And again, you could use this proportion right here by covering this one up. Okay, and you could find x by using these three covering up the middle as well. So if I wanted to find x, I would have 3 over 5 using the bottom row and the top row, and then I have x over 3. And when I cross multiply, I have x equals 9/5. Okay, so those are all of our answers, but really for all the pieces, but this is the one we were looking for.